Hello there and welcome to A2 Maths from June 2018, paper 1, and here we're looking at question 11, a binomial expansion question. So use the binomial expansion to show that this thing here is approximately equal to 1 plus 5 over 2x minus 5 over 8x squared. So what we're going to do is we're going to treat 1 plus square root of 1 plus 4x over 1 minus x, and the way we're going to treat this as a binomial expansion is we're going to write this as 1 plus 4x to the power of a half. Remember, half is the indice for square rooting, times 1 minus x to the power of minus a half. So if you've got something on the bottom of a fraction, you can write that as an indice of a negative, and it's still got the square root around it, so it's minus a half. So what we'll do then is we'll break this question down into two different parts. 1 plus 4x to the power of a half is going to go first, and then I'll do this one second, multiply the two answers together. So just a reminder of what the binomial expansion formula is. It's 1 plus x to the n equals 1 plus nx plus n bracket n minus 1 over 2, and then x needs to be squared. So that's the formula we're now using. It's in the formula booklet, so you don't need to memorize it. So let's get started. It's 1 plus, n is the value a half, so it's going to be a half. And the value of x is effectively 4x in this question, so it's going to be 4x. Then it's going to be plus a half. Then a half minus 1, that's minus a half, over 2 factorial, or just 2. And then it's going to be x squared, but x is not just x, it's 4x in this question, so it's going to be 4x all squared. Let's now simplify our answer here. We've got 1 plus 2x minus, this is going to be 16 inside the bracket here, this is going to be 8 here, so it's going to be minus 2x squared as we simplify that. Let's now do 1 minus x to the power of minus a half, using the binomial expansion formula, so it's going to be 1 plus, the n value is minus a half, and the x is minus x in this question. And then it's going to be plus minus a half times minus 3 over 2 over 2 times by minus x, all being squared. So simplifying this, it's going to give us 1 plus 1 half x plus, for the quadruple negative that we've got here, 3 over 8 x squared. So for the square root of 1 plus 4x over 1 minus x, this is approximately going to be the multiplication of 1 plus 2x minus 2x squared times by 1 minus x to the power of minus a half as the binomial expansion, so it's going to be 1 plus 1 half x plus 3 over 8 x squared. Now we need to expand the brackets, and any power that's more than 2, we can just ignore that. So it's going to be 1 times 1, that's 1. 1 times a half x, that's going to be a half x. 1 times 3 over 8x squared, that's going to be 3 over 8x squared. Next one's going to be 2x times 1, so that's 2x. 2x times a half x, that's going to be 1x squared. And the next expansion is going to give us a power of 3, so I can just ignore that. The last thing that we need to do is take away 2x squared for the final expansion, and then any other expansion is going to give us a power bigger than 3. So now grouping this all together then, it's going to be 1 plus 5 over 2x, and then this is going to be minus x squared for this part here, plus 3 over 8x squared, so it's going to be, minus 5 over 8 x squared. Great, so that's all worked out nice, and we've proved part A to be true. Moving on to part B and C now, a student substitutes x equals a half into both sides of the approximation shown in part A in an attempt to find an approximation to the square root of 6. Give a reason why the student should not use x equals a half. Well, for the expansion of 1 plus 4x to the power of a half only works when the modulus of 4x is less than or equal to 1. If we go back to what we actually see in the formula booklet, we see this thing here, but we also see when modulus of x is less than 1. In this question here, it's not x, it's 4x, so that's why we're having to put 4 here. Now, 4 is a positive number, so we can actually divide 4 out of the modulus brackets, so the modulus of x needs to be less than 4, or in other words, x needs to be in between minus a quarter to positive quarter, which does not include x equals a half. So we cannot use x equals a half in this approximation. Moving on to part C now, substitute x equals 1 over 11 into this expansion here to obtain an approximate to the square root of 6. Give your answer as a fraction in its simplest form. Okay, so first of all I'm thinking, well, why is 1 over 11 going to work in here? Well, let's put it in. It's going to be 1 plus 4 over 11 over 1 minus 1 over 11. I'm expecting this to appear as some scale factor multiple of the square root of 6. So 1 plus this, that will give me 15 over 11, and this minus this is going to give me 10 over 11. Yeah, that's 10 over 11, so this is going to simplify to 3 over 2, and if I now times top and bottom by the 2 inside the square root here, that's going to give us 6 over 4, which will then simplify to the square root of 6 over 2. So whatever answer I get when I substitute 1 over 11 into the right-hand part of this expansion, I'm going to need to double it to get my approximation for the square root of 6. So when x equals 1 over 11, I'm going to have 1 plus 5 over 2 times 1 over 11, and then it's going to be minus 5 over 8 times 1 over 121, because that's 11 squared. And then when I put this all into the calculator, I get, typing this all in, we get 1183 over 968. So that's what I get when I put that into the expansion. So effectively I've put 1 over 11 into this side of the equation, into this side of the equation, so I can now say that the square root of 6 over 2 is equal to 1183 over 968. But now to find an approximation for just the square root of 6, I now need to times the other side by 2, or times both sides by 2 effectively, and I get an answer of 1183 over 484. So there we are, that's our answer as a simplified fraction to answer part C there. So there we are, that's 10 marks for question 11 there. That's question 11, let's now move on to question 12.